Good evening, sir.
Yes. Good evening, Siddharji. Yes. Today we have to discuss whole chemistry. Yes.
Yes, sir.
Last day we have discussed thermodynamics and electrochemistry. Yes.
Not thermodynamics, sir. Electrochemistry we discussed and chemical kinetics we discussed.
Yes. Yes. Chemical kinetics and electro. Yes. Yes. Let me start. Introduce yourself. Briefly introduce.
Good evening, sir. My name is SubodhCheM and I live in Bhilwara, Rajasthan. And I've done my schooling from St. Anselm Senior Secondary School, Bhilwara. And after that, I went for my graduation to the Central University of Rajasthan. And after that, in 2017, I have qualified IIT-JEM exam and I got selected in Indian Institute of Science, Bangalore. And I have done my post-graduation from there. And in my post-graduation, I have qualified CSI NET exam in year 2017 and 2021 and GATE exam in year 21, 22 and 23. And recently, I am preparing for the government jobs.
Yes. Good. Good intro. Let's move on chemistry. Yes.
Yes.
The first of all, acid base. What
Yes,
is
sir.
acid base? Acid base.
Okay, sir.
What is acid and what is base?
So, sir, there are many definitions for the acid and bases. Like from Arrhenius, it is one definition. From Bronsted, there is one definition. And Lewis gave other definition.
Yes.
So, an acid is a compound or substance which give H plus ion in water. It was given by Bronsted concept. And the base is a substance which accept H plus ion in the water. But these are not appropriate definition because many acid and bases are not defined like that. So Lewis gave the correct definition that acids are electron acceptors and bases are electron donors. So these definitions can be applied on each and every substance, and by this we can define acids are electron acceptors and bases are electron donors.
Yes. Good. What is Bronsted-Lowry concept?
Yes, sir. Sir, Bronsted-Lowry gave the definition of acid and base, like he defined acid as those which give H plus ion in the solution, and bases are those which accept H plus ion in solution. For example, if HCl is there and it is dissolved in water, then it will go to H3O plus Cl. But if we are having like Cl minus, it will accept H plus and form HCl plus OH minus if water is used. So we can define like HCl is an acid and Cl minus is a base.
Yes. Good.
And Bronsted also gave one concept that of conjugate acid and bases. Like this is an acid, so the counter ion of this will act as a conjugate base, and if this is acting as a base, then its conjugate ion will act as an acid. And the strength of the ions depends upon the strength of the other ion. Like if the conjugate acid is much stronger, then the conjugate base of that ion will be much lower or much weaker. And reverse also. If conjugate ion is much weaker, then the other ion will be much stronger, acid or base.
Yes. Good. How to determine the pH and pOH? And what is pH?
Yes, sir. Basically, pH is a scale which defines the strength of acid and bases. Like pH, it is saying power of hydrogen. If we name the short form, it is power of hydrogen. And this pH scale was given by Sorensen. It is having a number from 1 to 40. So it defines like if the pH value is much lower, like from 1 to 7, if it is much lower, then it is acid. And if 7 to 40, then it is base. And one more thing, that lower the pH value for acid, it is much stronger acid. And higher the pH value for the base, it is much stronger base. So like this, it defines the concept of acid and base. That how strong we can acid and base.
Yes, good. What is buffer solution?
Sir, buffer solutions are the solutions which resist change in pH on addition of small amount of acid or bases. We can define buffer solutions. For example, if we have a buffer solution of NH4OH plus NH4Cl, then we are having a equilibrium established between NH4OH and NH4Cl. There is an equilibrium. So, if I add HCl, for example, to this small amount of like 0.1, then the equilibrium will be like NH4H plus HCl will go NH4Cl plus H2. So it will just interchange their concentrations by small amounts. So they will ultimately resist the change in the pH. Because if the concentration of both the ions, neither H plus ion nor OH minus ion, will change by much amount, and ultimately the pH will be almost same.
Yes. What is the difference between acidic buffer and basic buffer?
Sir, acidic buffers. The acidic buffers are those buffers which have more stronger acid ion or cation in the salt of buffer, and their pH lies below 7. And basic buffers are same thing, those which have anion stronger and pH lies above 7. pH is greater than 7. So like this we can define acidic and basic.
Yes. What is dilution law?
Sir, Ostwald dilution law.
Yes.
Okay. So, sir, whenever there is a weak acid like CH3COOH and it gets dissociated into its ions like CH3COO minus plus H. Since it is a weak acid, so there is not complete dissociation of the ions in case of CH3COOH. So whenever a solution is present, like for example, if we are having a solution of CH3COOH and if we dilute the solution, then the dilution law says that there is an increase in the dissociation of the weak acid on dilution, because ultimately the concentration of the ions changes on dilution, and for equilibrium to be stable, that there is more and more dissociation of the CH3COH in the other ions.
Yes. Next one is hard acid, hard base, soft base. What is the difference?
So, sir, like the power of cation we can define. If the cation is having more charge and is having less electronegativity, then it is more powerful cation. And if we define the hard acid, then we define it. This is a strong acid only, but in this the cations that are attached to the center. So the anions that are attached to the center, they are more stronger, like HCl, HBr, H2SO4. Whereas in case of the soft acid, we are having the anions which are attached to be more polarized and more stabilized, like CH3COH. And hard bases are those bases in which a strong cation like calcium hydroxide, NaOH is attached. And soft bases are those bases which are having least powerful cation. You can define it. If based on the amount of anion, strong effect of anion or cation, we can define hard acids and hard bases.
Yes. Yes, next move on point group. Yes, group theory. What is point group?
So point group. Sir, point group is defined as, since there are various symmetry elements as such, like the plane of symmetry or center of symmetry, CS, inversion center, or axis of rotation, or S. So there can be different type of symmetry elements. So whenever a molecule has some type of symmetry, so we can represent that type of symmetry in a 2D form of group, and that 2D form of group represents the symmetry in the higher order. Like for example, it can, whatever the maximum order of symmetry it can have, that can be represented with a 2D representation, which is called as a group, and this group is called as point group. So point group is 2D representation of the symmetry elements present in the molecule. So like this, you can define the point. And what is mean by 2D representation, I can tell. Like for example, sigma is there, and we know if the sigma is along the xy plane, and if we draw the matrix of that sigma, then this is known as the 2D representation of that symmetry. Like this, we can represent point groups also. So
yes, good. What is plane of symmetry?
yes. So by means of plane of symmetry, we represent the plane of symmetry by sigma, and there can be two types of plane of symmetry, that is vertical planes and horizontal planes. And in case of the plane of symmetry, if we pass a plane from the molecule, then the molecule which is divided by the plane is same on the both sides, or it is mirrored by the plane on the either side. Like for example, if we are having nitrogen and ammonia complex, nitrogen, and if we pass a plane from the one of the nitrogen hydrogen, then this hydrogen will reflect in this hydrogen. So A and B will reflect with each other. So like this, we can define the plane of symmetry.
Yes, good. What is point symmetry? Point of symmetry. Invergent center, center of symmetry.
Okay. Listen. So by inversion center, you mean if we move on backwards and forward side from the center of molecule, and if we get same environment, then we predict that the center or the invergence matrix. For example, if I am having a planar molecule like C, and this is the center. So if I move backward from here, I am getting C, I am getting C. And if I move in this direction, I am getting H. So again in this direction, I am getting H. And in this direction, I am getting H. So again in this direction, I am getting. So this molecule has inversion of symmetry.
Yes. Improper of axis of rotation.
Yes, sir. So it is denoted by Sm, and it is a combination of two elements, that is Cn into sigma. And by Cn we means proper axis of rotation, and sigma is plane, which is perpendicular to the axis of rotation. So it is written as sigma h. So Sn is defined as if we rotate the molecule by the Cn axis and reflect the molecule in sigma h, and we get the same environment, then the molecule has Sn axis. So it can be like, if assume we are having a tetrahedral structure of CH2, and in a cube we can represent as, this is hydrogen, this is hydrogen, this is hydrogen, and this is hydrogen. So these are four types of hydrogen present on the alternate coordinate. So if I rotate by Cn, that is C4, 90 degree. So what I will get, so this hydrogen will come here, we have hydrogen here, and I will have hydrogen here, this will move here, this will move here, and the other one will move. So I will have the rotation like this, here, and here, H, H, and H. Now if I apply sigma h means I reflect on this plane, then the hydrogens which are below will move upward, and the upward hydrogens will move below. So finally, I will get that hydrogen, this will move upward. So we can see that after Cn and sigma h, we are getting the same molecule. This and this are same. So we say that it has S4S. So like this, we can define S.
Yes, good. What is dihedral planes?
Yes. the dihedral planes, or we call them as sigma D, these planes. So these are present in the point groups which are having CN acid, sigma plane, sigma H, and NC2X. So the point group becomes in this case of D. So whenever there is a D point group and there are planes present, as for example, okay. So if there is a plane which is sigma V, usually called a vertical plane, which is bisecting, which bisects the angle between the atoms, then it is represented as sigma D or the dihedral plane. For example, if we have PtCl, and we know that this is a planar molecule, and if we assume this as Pt, then there will be a C4 axis in this and 4 perpendicular sheet which are in this plane, and there are 4 planes which are passing from the 4C2, in which the 2 are sigma D and 2 are sigma B. Why 2 are sigma D? Because 2 planes will be bisecting the angle which is formed by ClCl-Pt. So we call these planes as dihedral planes.
Yes, good. Good explain. Next, move on topic is spectroscopy.
Yes.
What is spectroscopy?
Sir, what?
What is spectroscopy?
Okay. If we define spectroscopy, we can define it is a tool used to study the properties of the compound or molecule by generation of the spectra. And the spectra is generated when light or electromagnetic radiation interacts with the matter. Like this, we can define the spectrum.
Yes, good. What is the difference between spectroscopy and spectrometry?
Sir, I don't know the answer. I will look for the spectroscopy.
Next is, what is the difference between wavelength and frequency?
Yes, sir. So, sir, wavelength so the wavelength is defined in meter, or it is denoted by lambda, and frequency is denoted by nu. So if we assume an electromagnetic wave, then the amount of crust and troughs, like this is one crust and trough, so the amount of or the number of crust and trough that a wave forms in a second, in 1 second, we define as the frequency of the wave, and the distance which is traveled by this wave, we define it as the wavelength of the wave.
Yes. What is electromagnetic radiation?
Sir, electromagnetic radiation is defined as radiation which is produced by combination of electric and magnetic fields which are oscillating perpendicular to each other and generating field in the mutually perpendicular direction. For example, if we are having these three axes like x, y, and z, and if we have electric field which is oscillating in this direction, and if we have magnetic field oscillating in this direction, then there will be a radiation of field generated in the mutually perpendicular z direction, which we call as electromagnetic.
Yes. What is UV visible spectroscopy? First of all, basic question from my side. What is the difference between inorganic, organic, and physical spectroscopy?
Okay, sir. So if we just compare those spectroscopies, then in case of the inorganic ions, when we study the properties of the elements like cations, we spec EPR spectra for measuring their paramagnetic nature. So in this case of ions or these molecules, whichever the spectroscopy is used, so we call that as inorganic spectroscopy. And if we study the molecules which are formed by the organic counterparts like CH4 or any other molecules like ethylene, so the spectroscopies which are used like NMR, UV, IR. So all these spectroscopy which we study for the organic compounds, we call that as organic spectroscopy. And in physical spectroscopy, we try to understand the physical aspects present in different type of molecules. Like we try to define bond length, bond strength, etc. So if we use spectroscopy for these purposes, we call that as physical spectroscopy.
What is the source of UV visible? UV. What is the source?
Sir, source is tungsten lamp, deuterium lamp. There can be different type of sources. Usually the tungsten or sodium lamp is used for emitting the light because we need a light of visible wavelength. So we use the light which is visible.
Yes, UV is source of deuterium and hydrogen lamp. Yes.
Yes, it can. Deuterium, hydrogen can be. Sodium lamps or xenon lamps we can use in UV. So
Yeah,
they can
visible
be
in tungsten iodine lamp. Yes.
that tungsten.
Yes. What is Beer-Lambert law?
Sir, Beer-Lambert's law. It defines that the absorbance is directly proportional to the concentration of ions and the path length. And if we remove the proportionality, we write epsilon Cl, where the epsilon is molar absorption. So this is Beer-Lambert's.
Yes. What is the application of Beer's law?
The Beer-Lambert's law can be applied to determine first thing absorbance in solution we can determine. Second thing, we can determine absorbance of the each counterpart if different ions are present. Third thing, we can use the Beer number of in spectrophotometric determinations for determining the concentration based on the absorbance. So like this, using this relation, we can determine.
Any limitation of Beer's law?
Yes, sir. First limitation is that it is applicable to the dilute solutions only. Because whenever the solutions are not dilute, there can be interactions between the particles which can affect the absorbance of the ions. So first, the foremost thing that dilute solution should be dilute. Second thing, which is from this also, that if solution is not dilute and absorbance is greater than 1, absorbance should not be greater than 1, because if it is greater than 1, then we are usually not able to measure that by the Beer-Lambert's law. And third thing, that light should be monochromatic. If polychromatic light is there and different wavelengths are there, then there can be a mixture in the absorbance of the solution phases. So the light should be monochromatic. So these are three limitations which I think.
Yes, good. What is electron transition in UV visible spectroscopy?
Sir, what question?
What is electronic transitions in UV visible
Okay.
spectroscopy?
Yes. So, sir, since we know from the atomic structure that there are many atomic orbitals, different atomic orbitals which are present. For example, n equal to 1 according to the principal quantum. So if we represent the atomic orbitals, we can write like this. And whenever a transition occurs from n equal to 1 to any other higher orbital, for example, n equal to 3. So when it comes back to the ground state, because since it is unstable, so ultimately it will try to come back, and when it comes back, it emittent is radiation. The radiation can be of two types. It can be of non-radiative, like it can be a energy loss by heat, or it can be of radiative type. And whenever there is a radiative transition, so they emit a particular type of spectra which we observe in case of UV visible. So this is the electronic transitions that happen in case of UV visible.
Yes. What is the difference between chromophore and oxychrome?
Yes. So, sir, chromophore. So, sir, chromophore helps in changing the wavelength. For example, if I have a molecule which is having a absorption spectra at 574 nanometer, and I add a chromophore, attach a chromophore to this, then its wavelength will change and it can increase up to 575 or 588 nanometer, 17 nanometer. But if we add an oxochrome, then it will just help in increasing intensity. Without altering wavelength. For example, if the 574 nanometer wavelength was there, then again we will observe the spectra at 574 nanometer only. But it can be a higher of intensity, the spectra. So this is the basic difference we can observe from it.
Yes. What is the difference between red shift, blue shift, the hypochromics effect, and hypsochromic
Yes.
effect?
So, sir, since we know that if we plot the absorbance versus wavelength, we get a particular type of curve like this of parabolic shape. Why? Because of the daily transitions and the Doppler effect, these broad bands are observed. So in case of the blue shift, so if we assume a vibgyor here, so we know that the blue is towards lower lambda. So the blue shift means shifting towards lower wavelength. Red shift means shift towards higher wavelength. Hypso and hypo. So in case of hypsochromic shift, we are having a increase in intensity. There is no shift from higher or lower towards higher or lower wavelength. The intensity at the same wavelength is increased, and in hypochromic this is decreased. The intensity is, so these are different type of effects which are observed in UV spectrum.
Yes, good. What is the role of Woodward-Fisher rules in UV spectroscopy?
Sir, Woodward gave certain rules which define the properties of the molecules which affect the wavelength or lambda. So by using the Woodward rules, we can determine the exact value of lambda that we will observe in case of the UV spectrum for organic molecules. The molecules can be of any type. They can be of alkene phase, they can be of carbonyl phase, or they can be of aromatic type. So the different type of molecules, we can measure the lambda by using the Woodward rules. So these were the rules which were used to determine the exact wavelength for the organic molecules.
Any limitation of Woodward rule?
Sir, they are only applicable to the organic molecules. First thing. Second thing, we can say that they are not considering the effect of many other groups which can be used. There are some limited groups only for which the wavelength is defined. For example, if we have cation in this case, and if we want to determine the wavelength at which it will observe, so there is no Woodward rule for determining the value of this. We are having like three concepts like alkene, carbonyl, and aromaticity. So based on that only we can determine. So this is one limitation. Or radical species we can have. So for that also we can determine the wavelength by using the Woodward-Hoffman rule, which are observing in the UV spectrum.
Yes, good. What is the difference between homoannular and heteroannular dynes?
Yes. So homoannular and heteroannular.
Yes.
Dynes. We are having a molecule like this, and the dye is present like this, that it is an homoannular dyne. And if we have a molecule like this, and the dye is present like this, then it is an heteroannular dyne. Because both the double bonds are present in different way, so it is heteroannular, and both the double bonds are present in same thing, so this is homoannular. So this is the basic.
Yes.